Okay guys, so we are going to do the last section in chapter 1. Okay, it's called Infinite Limits. Infinite Limits. So, I'm not crazy about how the book introduces limits, and they tell you at first that if the limit goes to infinity, then it doesn't exist. And then at the end of the chapter, they tell you, oh yeah, we were just kidding. Infinite limits do exist. So again, I'm not crazy about the way they do it, but they're certainly a lot smarter than me, so that's the way that I do it. So let's look at this function. F of x equals 3 over x minus 2. And when you first look at this, you take a look at that denominator of x minus 2, and we know that there's going to be something will be happening around 2, okay? So I go to my graph, and I hear 2, and there's a vertical asymptote at 2, and this graph does this, okay? And you can see that from your graphing calculator, okay? So we're going to look at the one-sided limits, okay? So let's look at the limit as x approaches 2 from the negative side of 3 over x minus 2, and then the limit as x approaches 2 from the positive side of 3 over x minus 2. So if we look at it from the positive side, that's this side. These are where positive numbers are from. We're coming from the positive side. What does this look like it's approaching? The answer is infinity. Okay? Here, I'm sorry, I said positive side and then I wrote it on the negative one. Positive side, infinity. From the negative side, that's where the negative numbers are. We're going here and that goes to negative infinity. Okay? So there are infinite limits. And the definition of that says a limit in which f of x increases or decreases without bound as x approaches c is called an infinite limit. So these are two infinite limits. Okay? So I'm going to give you guys a couple to try, and you can type them into your calculator and take a look. And you can always use the numeric method, type it into your calculator, look at a chart, okay, if it's unclear. But a lot of times with these, your graphing calculator will lead you the way. Okay, so let's say in part A, f of x is equal to 1 over x minus 1. And letter B, f of x equals 1 over x minus 1 squared. So what I want you to do is find the limits of each function as x approaches 1 from the left and the right. So this would be the limit of f of x as x approaches 1 from the negative side, the limit of f of x as x approaches 1 from the positive side, and then we're over here, the limit as x approaches 1 from the, whoops, we'll be consistent, we'll do negative first. Negative of this function, and the limit as x approaches 1 from the positive side of that function. Type those in and see what you get. Graphing calculator, please. Graphing calculator, please. Okay, so this first one, as we approach 1 from the negative side, when you type into your calculator, you should see that that's negative infinity. Okay, and then this one here is positive infinity, And then we go to these other two. 1 from the negative side. This one here should be infinity. And this one over here should be also infinity. We get infinity for both of those. Okay, if you have any questions on those, please bring those questions to me in class, and we'll take a look at them. So there's one last topic that we've got to cover in this section, and it's just to talk about vertical asymptotes. Well, we've already done some work with them. This is still under my infinite limit page. Need some new towels here. These things have been dirty for a very long time. So, vertical asymptotes. Vertical asymptotes. So if f of x approaches, if f of x approaches infinity or negative infinity, as x approaches c, from the left or the right, from the left or the right, then x equals c is a vertical asymptote. You guys have probably already seen this, okay? Of the graph of. So, you've already seen this. We've done some examples like this with limits, okay? You start to get a feel for it. So, vertical asymptotes. Make the denominator 0, but not the numerator, okay? So it's not just make the denominator 0, okay? Because if it also makes the numerator 0, then it's not a vertical asymptote, okay? Vertical asymptote is one that only makes the denominator 0. So, let me give you some problems to look at. Determine all vertical asymptotes. Okay, determine all vertical asymptotes. So A is going to be f of x equals 1 over 2 times x plus 1. B, f of x equals x squared plus 1 over x squared minus 1. And C is f of x equals cotangent of x. Okay, let me give you another one. We'll do a D. Well, D is going to fit in my viewing window here, but let's take a look. I think so. It's hard to see from here. D. F of x equals x squared plus 2x minus 8 over x squared minus 4. And that's going to finish off section 1.5. So do those, and then we'll take a look at them. Okay, so if you're not done, pause the video, okay? Pause the video, take a look, and then we'll go. But I'm going to get started. So vertical asymptote here would be x equals -1, because that's going to make a 0 in my denominator. This one here, x equals plus or minus 1. We have two vertical asymptotes. Don't look at this and think that you can factor that. You can't factor x squared plus 1. Okay, x squared plus 1 is prime. So now, cotangent x. All right, so let's think. Cotangent x. Let's think this one out. Cotangent is cosine x over sine x. So we need to think wherever sine of x is equal to 0. Sine is my y, so it happens at 0, it happens at pi, it happens at 2 pi. So I think you could say x equals n times pi. Okay, so it keeps repeating itself. When I look at this one, I'm going to factor the top. X plus 4, x minus 2, factor the bottom, x plus 2, x minus 2. So we look at this one, and your first instinct is to say it has two vertical asymptotes. However, these two things would cancel. So we actually only have one vertical asymptote, and that's at x equals, whoa, x equals a -2. Okay? So that is section 1.5. Hope you understood it. If not, ask me questions. Send me an email.